Chapter 10 Carboxylic acid and derivatives. Part 3 Acid anhydride. Definition: an acid anhydride is a carboxylic acid derivative in which the OH group is replaced by the alkanoate group R prime COO. OH of the carboxyl group is replaced by R prime COO alkanoate group. Its general formula is RC double bond O single bond O C double bond O R prime or RCO OCO R prime. R and R could be identical or different to each other. General molecular formula: ethanoic anhydride CH3 COO CH3 is an example of saturated open chain or non-cyclic, the same meaning, acid anhydride. The molecular formula of ethanoic anhydride: we have 1, 2, 3, 4 carbon C4, 3 and 3, 6 hydrogen H6 and 3 oxygen O3. C4H6O3, its molecular formula. In general, number of carbon atoms is represented by N, and number of hydrogen atoms 2N and other numbers. In this case, N equal 4, 2N equal 8, but number of hydrogen equals 6, we should subtract 2, then 2N minus 2. 8 minus 2 equals 6, then 2N minus 2. Therefore, it satisfies the general molecular formula CN H2N minus 2 O3. This is the general molecular formula of an open chain or non-cyclic saturated acid anhydride CnH2n minus 2 O3. We can use this general formula if we have the percentage by mass of any element. We can deduce N and therefore the molecular formula of the acid anhydride. Now, nomenclature. According to IUPAC rules, the systematic name of the symmetric acid anhydride formed of same carboxylic acid is derived from that of the corresponding acid by replacing the word acid with the word anhydride. First, we have two types of acid anhydride. If the R and R prime are identical, that means this acid anhydride is formed from the same carboxylic acid, as we will see in the preparation. Then the acid anhydride is called symmetric. When R and R prime are not identical, different alkyl group, therefore the acid anhydride is called mixed. It is formed of two different carboxylic acids. Now the nomenclature of symmetric acid anhydride, it is the same as the name of the carboxylic acid of which it is formed, but we replace the word acid by the word anhydride. The name becomes alkanoic acid. We replace acid by anhydride. The name becomes alkanoic anhydride. Example: this is the general formula of acid anhydride. This part is the rest of the first acid, and this part is the rest of the second acid. Rest of first acid and rest of second acid. When R and R prime are identical, the same carboxylic acid, then the name of the anhydride is the name of the carboxylic acid, but we replace the word acid by word anhydride. In this case, the central atom, oxygen atom, this is the central atom. HCO is the rest of first acid, and HCO is the rest of second acid. Same acid formed of one carbon, methanoic acid. We replace acid by anhydride. The name becomes methanoic anhydride. CH3COO COCH3 This is the symmetric central atom, oxygen atom. This is the first part of the anhydride, first acid, and this is the rest of second acid. Same acid, ethanoic acid formed of 2 carbon, then ethanoic anhydride is the name. Also, this part is from benzoic acid, and this part is from benzoic acid, then benzoic anhydride. Now, mixed acid anhydrides, which are formed of 2 different acids, are named with the names of the 2 acids but in alphabetical order followed by the word anhydride. Example, this acid anhydride is formed of 2 different acids. The first is methanoic acid and the second is ethanoic acid. E in alphabetical order before M, then ethanoic before methanoic, and we add anhydride. Then the name is ethanoic methanoic anhydride. This example is formed of ethanoic acid and propanoic acid formed of 3 carbon, E before P, then ethanoic propanoic anhydride. This is the nomenclature of acid anhydride. Now, preparation of acid anhydride. First, symmetric anhydride is prepared by intermolecular dehydration, elimination of water H2O, involving 2 carboxylic acid molecules. The OH group of the first acid, of the carboxyl group of the first acid, and the H atom of the carboxyl group of the second acid are removed with the formation of water, and an anhydride molecule according to the equation is formed. 2 acid, we eliminate OH from one acid and H from the other acid, we obtain H2O and we obtain the acid anhydride. This, the general equation, shows the formation of acid anhydride. This is the first acid, from it we eliminate OH, and this is the second, same molecule, same acid, we eliminate from it the hydrogen OH with H, produce H2O, and the rest of the first acid is RC double bond O, and the rest of the second acid RC double bond O single bond O. We obtain the acid anhydride plus H2O. But this reaction is incomplete reversible reaction because acid anhydride reacts with water to give carboxylic acid again. How to solve this problem? To make the reaction complete, it is carried out in the presence of a strong dehydrating reagent such as phosphorus pentoxide P2O5. The reaction becomes complete and we obtain acid anhydride because P2O5 absorbs water, is a strong dehydrating agent. It absorbs water formed in this reaction and prevent the reaction between acid anhydride and water. That means the hydrolysis of acid anhydride. That means the backward reaction, no backward reaction, and the reaction becomes complete. This is the role of P2O5. Now, for mixed anhydride. If we mix 2 different carboxylic acids, we heat them in presence of P2O5, a mixture of 3 anhydride is obtained according to the following equation. When we mix 2 different acids, when we put few milliliters of the first acid and few milliliters of the second acid, that means we put millions or billions molecules of the first acid and millions or billions of molecules of the second acid. There are 3 possibilities. First possibility, 2 molecules of the same first acid combine together to form or condensate together to form the first acid anhydride. Second possibility, 2 molecules of the same but second acid condensate together to give another acid anhydride, sorry, R prime CO O CO R prime, two different anhydrides. And the third possibility, one molecule of the first acid condensate with one molecule of the second acid to produce the mixed anhydride needed. In this case, we obtain three different anhydrides. How to separate them to obtain the mixed anhydride? We use fractional distillation. Fractional distillation depends on the difference in boiling point between liquids. But since these acid anhydrides have close boiling point, then it is difficult to separate them. Therefore, and the yield of the reaction is for the mixed anhydride is 33%, equal yield, 33 for first, 33% for second, and 33% for third. Then the mixed anhydride, the percentage of mixed anhydride is 33%. It is not accepted yield for preparation of mixed anhydride. Therefore, this method is not convenient to prepare mixed anhydride. We should use another method to prepare mixed anhydride. Therefore, we make a reaction between acyl chloride of the first acid, derivative of first acid acyl chloride, and the alkanoate of the second acid, R prime COO-Na. In anhydrous or dry medium, we will say why next. The reaction is RCOCl plus R prime COO-Na, acyl chloride of the first and alkanoate of the second. Cl plus Na give NaCl, and the rest of the acyl chloride RCO, and the rest of the alkanoate RCOO, R prime COO. We obtain the acid anhydride, the mixed acid anhydride alone and with yield equal 100% approximately. But the condition of this reaction must be carried out in anhydrous dry medium. Why? To prevent the hydrolysis of acyl chloride into carboxylic acid. In presence of water, acyl chloride undergoes hydrolysis. It is transformed into carboxylic acid. Then carboxylic acid with alkanoate, no reaction. Then no synthesis of acid anhydride. So that the medium should be dry or anhydrous to prevent the hydrolysis of acyl chloride. Hydrolysis of acid anhydrides. The reaction of an acid anhydride with water hydrolysis leads to the formation of two carboxylic acids according to the general equation RCOO-COR plus H2O give 2RCOH. If we have mixed anhydride, we obtain two different carboxylic acids, RCOH and R prime COH. Example, CH3COO-COCH3 plus H2O, we obtain 2CH3COH. Complete reaction. Characteristics of this reaction: complete, exothermic, and slower than the hydrolysis of acyl chloride. This is the third part of the lesson, acid anhydride.